Hello children, welcome to our next class, and today we will discuss about the equation of uniformly accelerated motion by calculus method. Before that, we will discuss about the importance or merit of calculus. Already you have done the chapter in mathematical tool, and there you have seen that calculus is a way of simplifying a statement or expression to the minimum or to the maximum value. That means for a physical quantity, we can go for the very instantaneous value by the calculus method, or if you want to correlate one body with respect to a vast body or vast expression, there also calculus is helpful. So calculus helps us to minimize or maximize the given data with its frames. So we are using the concept of both differentiation and integration in doing this expression. So what we have the relation, we have three quantities there, as already we have discussed in our previous video. There calculus method will also use to find the same relation. There the three equations are there. First is the VT equation, that is the VT graph, VT equation. So what is the quantity we get by V by T? Yes, acceleration, because acceleration is the ratio of velocity with respect to time. So the first equation, to find the first equation, what we will use, we will consider that a body is moving with some initial velocity at time t, then the acceleration of the body will be acceleration of the body for a small displacement dv and dt. The acceleration can be represented by this. This dv by dt is the differential representation of change in velocity with respect to change in time. So further we can write or a equal to or dv equal to a dt. You simplify this. Now we'll go for the integration. Integration we'll do with the proper limit. So integrating both sides with the proper limit. Whatever the limit for velocity, it's from initial to final. What will be the limit of time? It's t equal to 0 to t equal to time. Now we will substitute the value of dv. The integration of dv will be v. So it will be v. The limits are v and u. A. What is the integration of dt? That is t. So it is t. The limits are t minus 0. If you have any doubt in this integration part or differentiation part, please see the previous video of mathematical tool. Then after you come to this topic, because calculus is required for both the group. It's a PCM and PCB or PCMB. All three group needs the calculation, because without calculus it will be very tough to simplify the expression of physics in class 11 as well as in 12. So please, my humble request to you that if still you have not done that chapter of calculus in mathematical tool, you first complete that, then come to this side. So now we'll substitute the higher limit minus lower limit. So in place of v, the higher limit is v, lower limit is u. There a. What is the higher limit? T. Lower limit is 0. So may we neglect the 0, or let's write t minus 0. Now the last equation will be what? It will be v minus u equal to at. This is our first equation, which is giving the relation of velocity time equation by differentiating the quantity acceleration a equal to dy dt, and further we have gone for the integration. Please pause the video and write down the things on your copy. Now welcome to the second equation. What was the second equation? That was the distance time equation. So for displacement time or distance time equation, which quantity we have to differentiate? So which quantity you get by displacement by time? Yes, velocity. So for a small span of time, for small displacement, velocity of the body can be expressed as v equal to dx by dt. There dx is the small change in the displacement and dt is small change in the time. So further what we can write? We can write dx equal to v dt. Now try to recall what I have told in the graphical condition, that the quantity which we have defined we will restrict to that to quantity only. So we are finding the relation between displacement and time. Displacement and time. So velocity must not be there. So how will we remove the velocity? By the first equation. As we have got v equal to u plus at, so we will substitute that value. ds equal to v equal to u plus at. Is it dt? Now again we will go for the integration by proper limit. So we will write integrating both sides with proper limit. Integrating both sides by proper limits. When going for integration, then the limit for dx is from 0 to the displacement. So it's dx. We will simplify this one. So what we will write? We will write u dt. The limit will be 0 to t. Further, a will take it out. Now t dt. The limit will be 0 to t. These are the limits. Please take time, think. Because the displacement, what will be the limit? It's starting from 0 to the last time, starting from 0 to the final time. There also 0 to final time. Now we'll integrate the things. So integration of dx is x. So it will be x. The limit will be x to 0. There, the integration of dt will be t. The limits are t to 0. There a. What will be the integration of x ds or t dt? That is x to the power n plus 1 by n plus 1. That was the integration. Try to recall the rules. So there t 1 plus 1 by 1 plus 1. So directly we will write t square by 2. Limits. Here the expression and limits are coming same, so no confusion will be there. In a different form, when the constant will be given, then we have to do more simplification. So finally what we will write here? X minus 0 is x, u, t minus 0 is t, a, 1 by 2, t square minus 0. This 0 divided by 2 will be 0, so we are neglecting that. So what we have? It's half a t square. So this is the second equation of motion by calculus method, and there what we are finding the relation between distance and time with respect to the velocity, and after that we are integrating with proper limit. So we have got the second equation of motion. Please pause the video and write down the things. Okay. Now we will go for the third equation. The third equation is the relation between velocity and distance. So to find that relation, again we will go for the another quantity. Try to recall, is there a quantity which gives us the relation between velocity and distance? No, we have not any such quantities. Velocity and distance are directly not related with any physical quantities, but acceleration contains velocity and time, and velocity contains distance and time. So we'll go to the first equation, that a equal to dv by dt. Right? Now, if you are writing this expression as dv by dx into dx by dt, mathematically we are not disturbing this expression because dx and dx cancel. So it's a dv by dt. But doing so, what we have got this expression. What is dx by dt? That is displacement by time. What expression we are getting? Yes, that is velocity. So further we can write a this v dv dx. We have got relation, velocity and distance. So no time is there in the given equation. Now we'll go for the v dv a dx. Now I'll go again for the integration with proper limit. You can pause the video and can solve by yourself also. So what we are doing? Integrating with proper limits. So what will be the limits for the velocity from initial to final? v dv, it's a u to v. A, what is the limit for this? It's a x to 0. Now v dv, what will be the integration? It is v square by 2. So v square by 2 the limit will be v by u a. There it's a x minus 0. So finally what we can write here, it's a 1 by 2 higher limit minus lower limit. So it's a v square minus u square. There it's a only as. Let's see. Now if you shift this 2 to that side, what we can conclude? It's a v square minus u square equal to 2as. This is the third equation. So we have got the relation of velocity distance by the integration of the expression we have got from the expression of acceleration, and after that putting the proper limit. Pause the video and write down the entire thing. This is quite very easy. Just you write 2 or 3 times, then things will be so easy that it will be just like concrete to your brain. It will stay throughout your this education life. I am sure. Okay, so pause the video and try to write down the things. Okay. Now we'll move to the concluding part of this, where we'll find or we'll write down this equation of motion with respect to gravity. Equation of motion, write down the topic, equation of motion in terms of gravity. So what we will do, we will replace that acceleration by gravity. So what was the first equation? It is v equal to u plus at. There this is a, so we'll replace that by gravity. So we write that v equal to u plus gt. What is the second equation? Second equation is s equal to ut plus half at square. So when we are throwing a body or a body is coming down, that distance can be expressed as height. Yes. So in place of that, we will write h equal to ut plus half gt square, where g stands for acceleration due to gravity. Third equation is v square minus u square equal to 2as. Again, these two terms will remove. So it's a v square minus u square is 2gh. Things are quite easy, dear students. You please do practice by watching the video 2 or 3 times, and please write down the things in your copy, and in a certain interval time you keep revising the things. I hope you have understood all those things, but still if you have any type of confusion, feel free to message me on my WhatsApp number. Till then, thank you. Have a nice day.